Okay, so welcome back, and in this video we're going to be taking a look at using electrolysis to calculate the time a current will need to run or the current used in a process. So we'll take a look at both perspectives, so time or current. And really a lot of the same principles we used in the video of electrolysis calculating for mass we're going to have here as well. So really it comes down to the same initial steps. You're going to have a certain number of grams of a metal that is plated out. You're going to use the molar mass to get you to moles of that element. Moles of the element is going to provide the bridge or can be converted to electrons based on knowledge of how many electrons are required to make, separate the ion and the element. And then you can get from moles of electrons to coulombs using the Faraday constant. And then at that point you've got two options. If you know the amperage, you can get to time by dividing the coulombs by the current. Or if you know the time, you can get to current simply by dividing the coulombs by time in seconds. So really it works out either way. Just remember that the initial answer you're going to get in terms of time, if you don't make any adjustments to your factor label, is going to be in seconds. So with that being said, maybe we'll take a look at an example right now. So first example here, how long would it take to produce 20 grams of iodine crystals from a solution of iodine using a current of 3 amps? Just like with electrolysis for mass, the nice thing about these electrolysis questions is that you don't need to know the cell potential. It's not relevant for what we're going to be doing. We're assuming that enough potential has been provided in the opposite direction to get the electrolysis to occur. So we've got 20 grams here. Again, sig fig issues, so maybe I'll help myself out and call that 20 grams with a decimal point so I can at least have a few sig figs going on here. Iodine crystals, remember that that's going to be I2. This would be one place that people might have an issue. So molar mass on the iodine crystals should be somewhere around, let's see, 253.8 grams of iodine for every 1 mole of iodine. And then for every 1 mole of iodine, we're going to need to have 2 moles of electrons transferring. And for every 1 mole of electrons transferring, we're going to have 96,485 coulombs transferring. And now, because we know the current, I can get my coulombs into seconds. For every 1 second, according to 3 amps information, 3 coulombs of charge is going to transfer. So maybe I'll do an initial inspection and see how this looks. Looks like the result on this is going to be 20 times 1 times 2 times 96,485 times 1. And then I'm going to divide that by the quantity. So got to remember, put this bottom information in parentheses. 253.8 times 1 times 1 times 3. Get that all set together. So it looks like 5,068.8 seconds, which really would be adjusted more to like 5,100 seconds. But I'm not quite done yet. I think I'm going to try and get this into hours, because I know that for every 3,600 seconds, 1 hour will have elapsed. And so, with that in mind, I'm going to divide my value by 3,600. And now I'm getting a number that's much more reasonable for 2 sig figs. I'm looking at about 1.4 hours of time in order to get the 20 grams of iodine crystals from that solution of iodine. So that's the first factor label. You'll notice that it's not, it's almost like exactly the opposite of what we were doing in the previous factor label. So I've got one more example that we can take a look at here, and it's what is the current if 8 grams Okay, and so that should wrap up solving for time. You're just going to need to pick the best unit available, and then I've got one more example. This one should give us an opportunity to take a look at solving for current. So even though new substance, what have you, different grams, all that sort of business really doesn't matter because we don't need to know the cell potential. We just need to know the molar mass for the metal that we're looking at. So a very similar start to what we're going to be doing. 8 grams of tin is how much we're expecting to see plate out. So grams of tin to moles of tin, that's going to be a 1. And then the atomic mass for tin just so happens to be 118.7. And given the difference in the two metal identifications, we're looking at moles of tin going to moles of electrons. And for every 1 mole of tin, given the charge of tin that we're drawing from being 2+, we're going to have 2 moles of electrons needed to transfer. We know that, according to the Faraday constant, that there is a relationship between moles of electrons and coulombs. And this is really where the factor label stops for now. We need to get our coulombs value. And so 8 grams times 2 times 96,485 puts us at a pretty big number. And because most of the values along the bottom are just 1s, I'm just going to go ahead and do a straight division by 118.7. So, looks like we're going to have a fair number of coulombs transferring. I'm going to keep more sig figs than would be required here because mathematically I'm not done with my calculation yet. Because at this point now I need to get to current, right? And so current, and I'll write down the word current because otherwise that C could be confused with coulombs, is going to be coulombs, which I will now also write out, over seconds. And so as I'm looking at this, I need to do another separate factor label. 3 hours converted to seconds. And so 3 times 3600 puts us at 10,800 seconds. Now it gets a little bit tricky here. I mean, really with time, you're counting the number of seconds. So I could see that time may not be having an impact on our sig figs. But when it comes to this calculation, we're looking here at current is going to equal, as I wrote down, this divided by this. So the current should be, let's just see here, looks like the current's not too overwhelming, not surprising here. Current is about 1.2 amps. So typically this is how I'm going to approach a problem that's asking me to solve for current. I'm going to do a factor label to get to coulombs, and then from there I'm going to do a separate calculation of the amps by dividing the coulombs that I have by the number of seconds that the process was being run. But really, these problems just come down to your ability to set up the factor label, remembering relationships. What's the relationship between moles of electrons and the element that you're working with? Remember the Faraday constant for the relationship between moles of electrons and coulombs. And then remember the relationship between moles of the substance and the mass of the substance. And then whether you're solving for current or possibly even solving for mass, right? Those relationships still exist. And the last one that I didn't mention was the relationship between coulombs and seconds, which you're going to get from the current. So again, hope this helps you out. Good luck.